running an app on Express. In this video, we'll expand the skeleton app we created in the last video, add further middleware packages for extended logging and security, share some mock data between our groups, and modify and send this data to clients. In our last video, we used the Express Generator CLI tool to generate an Express app skeleton for us, and in this video, we'll make use of this skeleton. If you didn't create an app skeleton in the last video, go back and follow the instructions to do that now. As we'll be using Express as an API server in this example, we won't be serving any HTML or other assets, so let's go ahead and clean some things up. First, delete the public and views directories. We can also remove the user's router. Now in the main app.js, we need to make some changes. Let's remove the reference to the user's router, clean up the view engine setup, disable static file serving, the user's root, and change this error handler to use the create error middleware to serve a 500 error. We'll pass along the core error, but this won't show up in production. We can also head back up and remove the reference to the path module. While we're here, let's change all these vars to consts. Now that we've cleaned up our app skeleton a little, let's add some additional middleware. By default, Express is not overly secure, doesn't set a variety of HTTP headers that are useful, and it exposes information about itself via other HTTP headers. We can make use of the Helmet middleware to take care of these issues for us. Let's install it now using npm. Make sure you're in the correct directory for the app skeleton, and then it's npm install. Now that it's installed, we simply require it into our application. And then tell Express to use it. We already know that Express will show debug information if we set the appropriate variable like this. And as the debug module is so powerful, I'd like to go ahead and set up some more of our application logging to use this module. By default, the Express skeleton uses the Morgan middleware to handle logging of requests and other things like that. So we just need to tell Morgan to use the debug module to do the actual logging instead of just logging straight out to the console. We can achieve this with the Morgan debug npm package. Let's install this using npm. And now we can just require that in. Remove the default Morgan require and tell Express to use this new logger instead. We need to tell the Morgan logger to use the name of our app, which is still my app as it's the default. We want to use the namespace of server. Just one more thing to install now. This will help us during development by automatically restarting our server whenever we make any changes to any of the files. This is another CLI tool, so make sure to install it globally, and this is Nodemon. Now we can start our app just by running Nodemon. As you can see, app has started and it's listening. We've got the output from the debug module, and if I was to make change, you can see when I save it, Nodemon automatically restarts the server. Now that our app is all set up, let's create some data for our API to work with. We're going to create a basic API for a library, so we're concerned with books, users, and the loans of books to the users. Let's create a data.json file and populate it with some entries. Obviously, in a real application, you'd make use of a proper database tool and not use a flat file. This is just for the purpose of a simple API Express app. So, create data.json. We'll put some data in here. So here's our array of book objects. Each book has an ID and a title. We've got an array of users, and each user has an ID and a name. And then we've just got an array of loans, which objects that contain the ID of a book and the ID of a user. Now that we've created our data, let's import it into our app using require. Require automatically parses JSON files for us, so we don't need to worry about doing that. As we aren't using a proper database solution, we need to have a way to share this data between the different routes of our API. Luckily, Express has functionality for this in the form of the app.locals property. App.locals is an object, the values of which persist through the lifetime of an application. We can access app.locals anywhere that we have access either directly to the app object or via the request object using request.app.locals. Let's assign our imported data into app.locals now. I call it data, but you can really call it anything that you want to. Again, this isn't a substitute for a proper database. We're opening ourselves up to race conditions if we mutate this data in one of our routes and all sorts of other things like that. So in your real applications, you're going to want to investigate one of the many database solutions that exist for Node. Now that we've finally got some data into our application, let's write our first routes. We'll rewrite this index route that the Express generator created for us. Let's change this default route to be the route for listing books. Now, we can access our list of books from app.locals by using the request object that gets passed into this function, and that contains an app property, which then contains the locals property, which is our app.locals object. We can then pull the books array from here using destructuring. And don't forget that I call it data, so we just need to reference that. Now we can send this list to the client. Let's give this a try. Looking good. We can see here in our log that someone tried to get the /books route, that's us, and then we can see that Firefox has helpfully converted this JSON object out into something that we can navigate around. We can see the raw data if we wanted to. Let's make a new route for listing users. Basically the same functionality as listing books. Let's test this. Great, that seems to work as well. What about loans? Okay, that works. The loans endpoint doesn't really provide any meaningful data to the client though. It would be great if we could directly see the names of the user and the names of the books that they've got on loan. So let's expand our loans route and add this functionality. First up, I know that we're going to need the list of books and the list of users, so let's destructure those as well. And then we somehow need to transform this list of loan objects into a list of objects that contain the properties of both the book from the books list and the user from the users list. There's going to be a few ways of doing this, but an easy way I can think of is to use the map method on the loans array. So the map method will iterate every entry in the loans array, pass it through a function, and then whatever value we return from that function will end up in a new array the map method creates. So this never mutates the data on the original array. You get a new array out the end. Now, we know that every loan is made of book ID and the user ID, so we can destructure these properties. We know that the book ID and the user ID is relevant to each loan that we're iterating, so we can use those IDs to find the book and user objects from their own arrays using the find method. So what we're saying here is look in the books array and find the first result that matches our test here. So we're saying look at each book and does the ID property on that book match this book ID that we're asking for? We'll do the same for user. Now we just need to return a new object that contains this data. And then we just send this new array to the client. Let's try this. Great. So we can see this book was loaned to this user, this book to this user, and this book to this user as well. So that's great. This looks like a much more informative endpoint now.